Welcome back everyone to another video in our FE Civil Preparation course. In this video, we are going to continue with laboratory and field tests on soil. Atterberg limits are the values that represent the percentage of water content needed for a specific soil to transition between solid to plastic to liquid state, and this property is only for cohesive soils. If we try to show a graph for this relation, we will have the water content percentage in the x-axis and the total volume of soil in y-axis. The relation between the water content and the volume of soil is as shown here. The soil volume remains constant as the water content increases in the first stage only. After that, the soil volume starts to increase. So first, when the water content is at its lowest value, the soil will be in its solid state, as we can see here. If the water content in the soil started to increase beyond this limit, the soil will start to expand till it reaches the semi-solid state, and this limit is called the semi-solid state limit. If the water content kept increasing beyond this limit, the soil volume will keep increasing, and after a while, the soil will transition from semi-solid state to be a plastic state, and this limit is called plastic limit. The same will keep going till the soil passes the plastic state and finally gets into the liquid state. Those limits here between each state are what we call Atterberg limits. We can see here that PL, which is the plastic limit, is the percentage of water required in order to get the soil into the plastic state. And LL, which is the liquid limit, is the percentage of water required in order to get the soil into the liquid state. Based on these values, we will be able to calculate what we call the plasticity index of the soil, and it equals to the liquid limit minus the plastic limit. It is a very simple equation, but a very important equation because it will help us in classifying the soil, as we will see later in the next videos. Now we are going to talk about a different test, and this time it is field test, which means it is carried out in the field. It is very simple and low cost test that we can use to identify the compactness of the soil, and based on it, we will be able to estimate the bearing capacity of the soil. In this test, we create a borehole at the location we want to test the soil at, and then we construct this tripod on top of it, and the attached guide rod on top of it. It includes a hammer with weight of 63.5 kilograms approximately. And we start hammering the soil, and we count the required numbers of blows to penetrate the soil between 0 and 15 cm, and between 15 cm and 30 cm, and between 30 cm and 45 cm. And the SPT N number is the required number of blows to achieve 30 cm penetration between the depths of 15 cm up to 45 cm. Based on this table here, if the numbers is less than 2, it means that the soil is very soft and it is expected to have ultimate bearing capacity less than 25 kilopascal, and between 2 to 4, it means that the soil is soft and expected to have between 25 up to 50 kilopascal ultimate bearing capacity, and the same goes on till we reach 30 numbers of blows, which means that the soil is hard and expected to have over 400 kilopascal ultimate bearing capacity. So this is it for our video today. In our next video, we will start with the soil classification. Thank you.